Hello everyone, welcome back to another remote sensing lecture video. And in this lecture video I want to go through the first set of examples talking about the four different types of contrast stretching. So this first example is the no stretch. And what I want to draw your attention to is we have this table over here on the left. These are the different categories that are going to be important to keep track of. So we have the potential, possible minimum, and the possible maximum. So these are the full range that is dictated by the radiometric resolution of the sensor. So in this case, the Landsat image that we drew this from went from negative 32,000 to positive 32,000. Then we have the actual minimum and the actual maximum. So these are the lowest and the highest pixel values that were actually used. So you can see that in this case, right, most of them weren't used, right? The range here is much less than the range here. Then we have the mean, which is just the average of all the pixel values. We have two standard deviations above the mean. This is going to be used for the standard deviation contrast stretch. Two standard deviations below the mean. Again, this is going to be used for the standard deviation. Then we have the lower 5% cut and the upper 5% cut. And these are going to be used for the percent clip stretching. So what I want to do is I want to go through all of these examples and I want to just see where these pixel values, right, where the pixel values that represent these important pieces end up in terms of their display values. And I'm going to draw some lines sort of showing where they end up. So the first one here is if we do nothing, right? No stretch. And again, for no stretch, right, the actual min becomes, I shouldn't say actual, sorry, the possible min becomes 0, and the theoretical or the possible maximum becomes 255, and everything sort of gets linearly interpolated in between. So what will happen in this case, right, the theoretical minimum becomes 0, the theoretical maximum becomes 255. That's what these two rows are doing. Right, and then all of these become all of these. And so what I want you to draw your attention to here is the fact that the actual minimum to the actual maximum only take up 9 display values. So the full range of the data set only takes up 9 display values. So this means the image is going to be basically one color. And if you load the image in, you might think it's broken, right? You might think you've corrupted the data, but you haven't. It just means that you're on a histogram stretch, in this case, no stretch, that is forcing all of your data into 9 display values. All right, so you can see these points are basically on top of each other. Okay. So let's talk about MinMax stretching. Right, MinMax stretching. So in MinMax stretching, right, in this case, the actual min becomes 0. The actual min becomes 0. And the actual max becomes 255. Right, that's what this is saying here. Right, this becomes 0. This becomes 255, and again, everything else gets linearly interpolated back. Now, this is where contrast stretching gets a little important. Anything above what we call 255 will also be 255. That's why this potential maximum or possible maximum is still 255. Anything below what we set to be 0 will also become 0, and that's why this possible minimum is 0. So what happens? Well, now we've taken this dot and we've set it here, and we've taken this dot and we've set it here. So all these dots right here now get expanded, right? And you can start to see differences in pixel values. Right, whereas before, this whole range took up 9 display values. Right, let's scroll back up just to sort of reiterate that point. Right, this thing right here, these points took up 9 display values in no stretch. But with MinMax Stretch, we've already stretched this out. You can see that a lot of the pixel values are still really small. And that's because you probably have a few pixels with really high values that are really messing with this min-max stretch. And that's why things like percent clip and standard deviation are so useful, right? Because there's probably 2 or 3 pixel values that are way up here. So everything else gets put way down here, right? The mean goes to 53, right? It's probably not ideal. You'd want the mean to be more in the, 120, 130 range. So that's min-max, right? Actual min goes to 0, actual max goes to 255, and we can start to sort of see these different critical values spreading out a little bit. Still not great, but it's an improvement. Let's talk about percent clip. So again, percent clip removes lowest percent and removes highest percent. So what I've done is I've gone ahead and calculated 13 is the pixel value. Anything lower than that is in the lowest 5% of the data. 349 here. Anything higher than that is in the highest 5% of the data. So this is going to become our new 0. This is going to become our new 255. What I want you to notice here is that this lowest 5% is greater than the actual minimum. So the actual minimum becomes 0, and it's definitely higher than the possible minimum. So the possible minimum is still 0. So we now have 3 things here that all became display value 0. Same thing with the maximum. The highest 5% cut is lower than the actual maximum, so that still is 255, and it's lower than the possible maximum, so that's still 255. So what have we done here? Well, it's hard to see here because they're basically collapsed onto one point, but there's 3 points in here that became that and that. All right, so this is the mean. This is mean minus 2SD, and this is mean, try it without the chicken scratch. This is mean plus 2SD. All right, so you can see percent clip, right? This was the minimum. This was the lower 5%. This was the higher 5%, right? So this was all stretched. Now you can see we've really spread apart the data. In the next example we go through, we'll actually look at some imagery that shows this. So hopefully that makes sense, right? We're just kind of spreading those pixel values out across more digital values, display values, by choosing smaller and smaller ranges of pixel values to include. Right, we're bringing these values. We're bringing the lowest pixel value and the highest pixel value closer and closer together. So finally, we have standard deviation. And standard deviation is typically going to produce the brightest image because it's going to exclude. Typically, it's going to exclude the most pixels. So let's put that in an asterisk. Right, typically going to exclude the most pixel values, and as a result, make the brightest image. Okay, so let's look at what we're doing here. So in this case, right, we're using the mean minus some number of standard deviations. In this case, we chose to use 2. So the mean minus 2 standard deviations, right, this becomes 0. And then the mean plus some number of standard deviations, in this case 2, becomes our 255. So that's what this is showing right here. Right, 2 standard deviations above becomes 255. 2 standard deviations below becomes 0. So now you can see we've made basically everything above the standard deviations is now 255. So that's this number, that's the 5% higher, that's the actual max, and the possible max. So we have a lot of pixels right now that are going to have a pixel value of a display value of 255, and a lot more pixels now are going to have a display value of 0. But everything in between these, so the mean plus or minus 2 standard deviations right now is going to be stretched out amongst the remaining pixel values. So you can see here that we've stretched out even farther because now this, right, this is now mean minus 2SD. And this is now mean plus 2SD. So let's just quickly go back and let's sort of see how those values have moved. Right, so in this no stretch option, right, the mean plus 2 standard deviation and the mean minus 2 standard deviation was somewhere in this little cluster. We couldn't even differentiate them. Right, in this example, right, the mean minus 2 standard deviations was right here. The mean plus 2 standard deviations was right here. We can see them, but they're still kind of really close together relative to the rest of the data. In percent clip, right, now we've really started to tease them apart. And in standard deviation, now they define the ends of the display values. I know this was a lot. Hopefully it makes sense. We're going to go through another full set of examples in the next video to sort of reiterate these points again. So hopefully this makes sense. And as always, please reach out. Thank you.